Hey, welcome back to the channel. Good to see you again. Thanks for joining. Hope you're all well. Today on the bench I have a Harman Kardon AVR65. It is a beast. It is massive. And it's heavy too, so it must be pushing some power. Now, I know you guys are groaning right now. Oh, it's an AVR. It's junk. Well, yeah, I agree with you. But to tell you the truth, a lot of my AVR videos actually do pretty well on YouTube. So I think a lot of my viewers want to see this. I don't know, you tell me below, but I do get a lot of a lot of hits on my AVR videos. I'm not a big fan of AVRs. They kind of try to do everything and they're really not good at anything. I don't know if that makes sense, but this one came to me. I bought a lot of equipment. I think it was 5, 6, 7 pieces, and some of them I just completely scrapped. And some of my, well, they were fair condition, so I hung on to them. This is one I hung on to. I don't know why. But, yeah, like I said, AVRs, they do have a place. The nice things about these AVRs is you can get a remote for these. This one doesn't have a remote, but you can get one on eBay for 20 or 30 bucks. Not a problem. And then you have a full function remote over your audio video. This is a very dated machine. It is huge. Okay, it's a very dated machine. It has no HDMI inputs. We're still working with RCA composite or super video, which is really limited to what you can do with this. There's good inputs. We have tape monitor. We have I think there's 3 video inputs. Here's a video input in and out. So okay, they're using that like a tape loop, DVD, CD. There's no phono on this. That's the problem with these AVRs. A lot of these, they dumped the phono section out of them because they just assumed people didn't want to use them anymore. Everybody was into watching DVDs and movies that way and getting their music digitally. This has been a build date of 1998 of November. Okay, so it's very dated. We're pushing close to 30 years now. But like I said, these still have a good following. People still have these and use them because they were made in such large numbers. Has a tuner built in, which is good, AM, FM. And then the inputs we talked about. Digital input, coaxial. What else do we have? And then we have very limited video control, which is usually just at this point in time is a joke. Front, left and right. We have a center channel and surround, left and right. Now, just before I turn the camera on, I was looking for some specs on this. We're going to get 75 watts channel out of the front, 65 watts channel out of the surround and center. So that's all channels driven. We do have a 6-channel direct input. Got front left, subwoofer. This does not have a subwoofer amp. It has a subwoofer out. So we can stick direct in, but if you want to use subwoofer, you better get an amplified subwoofer. Alright, so this came to me, and the previous owner wrote this down. It says, right channel doesn't work, everything else good. Alright, let's see about that. Alright, screws are out. I don't know where the screws went. I think when I received this receiver, I took the lid off and I did some cleaning because they were pretty nasty inside. So I think this has been cleaned. The lid's been cleaned anyway, partially. And I think I went and blew the dust out of this. So we should be good for any mouse droppings or anything like that. But wow, look at this thing. It's stacked with stuff. We have lots of stuff. Look at all these caps. Incredible. That's our input board. This is our input board. This is our tuner board, input board. This one is this one has our optical, coaxial, remote control, multi out, and then it has our preamp out. So this is some stuff going on here quite a bit. This is our video board, and then this is another video board. Amplifiers are all down. It's all discrete amplifiers. So it looks like you got 1, 2, 3 channels on this heatsink. And then if I flip around here, we have 2 more channels down here. So 5 altogether. Power supply board here, which has backup power and power probably for the system control and remote control, whatnot. Keeps it alive even when it's shut off. Big, huge, honking power transformer. Yeah, so lots going on here. It says 1 channel's out. See a lot of power supply stuff going on under here. Some nice sized heat sinks. Might have some cook capacitors, who knows. Bridge rectifier. And then we have, here we have, looks like we have 2 power supplies for our amplifiers. This one's 8200 microfarad, 63 volts. And then we have one over here, 6800 microfarad, 50 volts. So this is probably for the 60 watts amplifiers, and this is probably for the 75 watt amplifiers, I'm guessing. It's hard to say. It does have like a 2/3 removable bottom, which is awesome for an AVR, because typically these, you have to just tear these all apart to service them, which just makes them a pain to work on. Okay, so let's hook this up and see if we can get some tones through it, or at least make some noise. Okay, I thought it was a 2/3 bottom, but it's not, so it's just a panel. Remove it, and it gives you access to the bottom of the main board. Full power supply here that looks like a little bit cooked. Now I do believe somebody's been resoldering this. This looks like it's been all resoldered. Somebody reflowed a lot of this. Plus there's a foam block missing here. Now that didn't just fall out, it was removed. One of these foam blocks, and these are petrified. They're pretty hard. So big thing on these is the interboard connectors. All of these, they can develop solder cracks, so you have to inspect those with a lens and resolder them as needed. But it looks like somebody's gone in here and done a lot of work resoldering a lot of stuff. So it was serviced sometime in its past, but that's good. A little less for us to do. Okay, like I said, let's get some speakers and let's hear it. Okay, speakers are connected. My watt meter, let's plug her in, and we get 0. Some power factor here. Must be a capacitor. Okay, so the nice thing about this AVR is it has a front Kerchunk power switch, and then it's got a soft touch power switch. So if you go on vacation, you can shut it off. It doesn't consume any power while you're gone. It won't come on at random. So let's turn this power switch on. I'm up to 8 watts. It's settling down around 5. Okay. So let's turn it on. Ooh. Watts. $60 watts. Quite a bit of big power hog here. So I do have, let's turn down the volume. I got my source on tone on CD. Okay, there's our tone. Left channel, right channel is out. Another nice thing is it has potentiometers for the bass, treble, and balance. Here's their bass. They sound Okay, so we have no right channel. Why is that? Speaker. Okay, I'm going to play around with this, see if I can get my right channel back. And I'll bring you back in if I find anything. 77 watts and climbing. I don't like this at all. This is like something is seriously wrong with this thing. I hit the mute. Figure out where all this heat is going. Okay, it's going in directly into the 6-channel direct. Let's turn this on. And let's hit our, where is it? 6-channel direct. I saw the button here somewhere. 6-channel. There we go. So balance control doesn't work at all. We still have no right channel. Now we're down to 55 watts. I don't know what's going on with this thing. Let's try. The power's climbing up. Yeah, I'm going to keep playing with this. I'm feeding a signal directly into the surround amplifiers, the left and right, and they're both working. So yeah, just the one channel is out, the right on the front. So we're going to have to do a little bit of troubleshooting here. Okay, the plot thickens. So I got a line here, this yellow line, that's going to my scope. That's preamp out. And we can see on the scope got a signal on the left channel there. It's really fuzzy. As I turn it up, you can see that's our preamp out. So I'll switch it to the right channel. Here's the right channel. Same thing. Preamp's working. Power amp isn't. So that's a good start. Okay, here's a look at the block diagram. There's quite a bit going on here, so bear with me. So all on this side we have our inputs. We have our tape monitor, video 1, 2, DVD, CD, video 3, and our 6-channel inputs here on the bottom. Okay, and then on this side we have our preamp outs. We got our multi-room output, front, center, subwoofer, and rear. Now you gotta. It's really confusing because they don't have front, left, or right. They just say front, and they draw it as one output or one input. But in reality, it's stereo, so there's two channels, but they're only showing the one as a composite. And here's our power amps. Here's our output for the speakers. Protector, thermal protector, DC overload, thermal protector. It just shows a block. It doesn't show anything. So we know that we're getting a signal in on both our CD and our 6-channel, and it's going through all the switching. Except this bypass record selector. I don't know what this is, bypass record selector. I haven't played with that. And the multi-room, I think I turned multi-room off when I was playing with it. But regardless, we're getting a signal here on the output, preamp output, right here on the front. We're getting a signal on both channels. So going back to here, we have a signal at this point. And this transistor is a muting transistor, so this will mute any signal on either of these lines. It's called line mute. So we have a problem here, somewhere in here, that is, the signal's not getting through. Pretty much eliminates everything else, that considering that we have a preamp output signal here. So let's try and figure that out. Okay, so here's the main board. This is our front amp left here on top with the pink line showing the signal path through the circuit. And this is our front right amplifier right here. So this is where our trouble lies. So I need to go through here and check, make sure we have rail voltages first of all. And then I'd like to find out where the muting transistor is. I don't know if the muting transistor is here or probably some other board. The thing is, it's not showing protect. So this is the protect circuit here. This is a DC detector, a thermal detector. It's got a thermistor, and then this one just tests DC offset, I'm assuming. And then, yeah, back here, well, you can't see. Back here we got power supplies. These are all 3-terminal regulators. And then our bridge rectifiers. So this is all voltage regulator, power supply back here. We might have no, we would have all our voltages here because the left channel is working. So get into this and figure out what's going on with this circuit here. Follow the input signal. This is the input signal, this pink line for the left channel, and then the right channel is right beside it. So this comes from HU116. I don't know which HU. That's from the analog function assembly. Okay, so this is where a signal comes in for that amplifier. So we might have a problem on this analog board. I'm just trying to figure out where our, yeah. We might have to pull this board out and have a look at it. Alright, like it or not, the back panel has to come off, because if you want to start pulling any of these cards out, you have to have the back panel off because you won't get the card out, it's locked in. So the easiest way is just get a drill and just go to town. That's why people hate working on these, because there's just so many damn screws on the back panel. There's 50 screws you got to remove, and then yeah, it's time consuming. But I'll play with this and I'll bring you back. Yeah, now when you get the back cover off, things get a lot easier. So you just put this aside, and then you can start removing boards. And putting these aside, you can inspect them for cracks. You're going to find cracks along some of the connectors, possibly. And the input connectors will be cracked from stress. So this all aside, and this is where we're trying to get into here. Trying to get to the main board here, but I got to get some stuff out of the way first. That's what the goal is here. So we can remove some of this stuff and take pictures of where it goes if you want, and should be all laid out in the service manual for you. But if you want, you can take pictures of where these cards come from, where these connectors plug into. Makes it easier for you. Alright, according to the part numbers going by the service manual, these are 400 series parts here. This is 500 series parts, so they all start with R, like R516, C506. These start with 500. So this is the center channel here, and these are the left and right. So this is all left, this is odd number parts, and these are even number parts. So these are all the right channel here in the center. So I got 2 transistors, 2 drivers, I got my emitter resistor there in the center. I'm going to flip this over, and I'm going to start doing some checks on all these semiconductors and these emitter resistors, make sure they're not open. We could have an open fuse resistor. Looks like there's fuse resistors everywhere here. But our problem has got to be here somewhere. So I'm going to take a look at this. Okay, so this might be real difficult for you to see. There's a lot of information on these schematics. Okay, so this area here, this white space here, this is the division between the left and right channels. Everything above it is left channel. This block here is right channel. Okay, that's where we're focusing our attention. Now, I went through and checked the output devices. These 2 transistors here, they're not shorted. I checked the emitter resistors, they're not open. I checked the drivers, they're not shorted. So everything here is good. So we're not getting a fault condition where we have DC coming out on the speaker outlet and it's tripping to protect. That would make sense, because if any one of the 5 channels had a DC condition, DC fault condition where it was outputting DC, the protect circuit would shut down the entire amplifier. It wouldn't just shut down one channel. That's how these things work. They sense each channel, but if they detect a fault, they shut everything down. Also, on the input side, right here we have this diode and this diode. This one's for the left channel, this one's for the right channel. This is our turn-on signal for the amplifier. So as power on delay, it goes through this FET, and then it turns on the long tail pair. And now this signal is working because we have left channel working. If this is going to fail, it would fail somewhere here rather than somewhere on the other end of this. So what are we looking for here? What we have is all these fusible resistors. There's a whole bunch of them. And if you look around the circuit, everything's protected with fusible resistors. So we have fusible resistor here, for example, in between these two drivers. We have fusible resistors here and here on the outsides of the drivers. Fusible resistor here and here. This is the biasing circuit. And then we have fusible resistors here and here, 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 here. Like seems like every leg is protected with a fusible resistor. They even have them inside here. Now, I'll save you some time right now, and I'll tell you what I found. I went through and I found an open fusible resistor here, R448. Now this fusible resistor is on the negative rail, and it protects all of this circuitry here. There's a fusible resistor on the positive rail, 446. That one's intact, but this one's open. So what happened to cause this fusible resistor to open and disable this amplifier? I don't know. It could be, we could have a shorted transistor. We could have a shorted capacitor. Like back here, we have two capacitors on the rails. We have one on the positive, one on the negative. Let's see, 424 and 422. They are 470 microfarad at 50 volts. Okay, we might have a failed capacitor that could have shorted this. But this is a 10 ohm resistor. They didn't put this resistor in here to drop any voltage. They put it in there just as protection. So I'm going to poke around with my diode check on my voltmeter, on my digital multimeter, and I'm going to check these transistors just to make sure that none of them are shorted. I could actually check them all. There's like 10 transistors here. Wouldn't take me long. And if everything's okay, I should check that diode as well. Actually no, because this one's protected with a 560 ohm resistor. This would blow long before this would blow. I happen to think this resistor just failed just from maybe age, or maybe it's defective. It's a 10 ohm resistor, quarter watt. So I could calculate how much current it would take to pop that resistor, but it doesn't really matter. We know it's open. If we replace it, I'm going to do some checks to make sure these transistors are okay, because we have a couple 150 ohm here, 150 ohm here, 560, 560, and yeah. Alright, I'll check these, and I'll repopulate that resistor, and we'll see what happens. We should get our channel back. Alright, so let's have a look at this. So I hope you can see this. Let me turn down the volume on the light here. So the failed resistor is in the shadows here. It's right here. This is R448, and it's open. Now I checked the other transistors. Like I said, this is Q424, 420, 416. All these transistors are testing fine. These are the here's two big caps here, the 470 microfarad at 63 volts. These are bypass caps for the rails after the resistor. So I haven't checked these caps yet. I have a feeling they're fine, but I can test them, make sure that none of them are shorted. So I think this resistor just failed out of fatigue, and you know, every time you turn the amp on, it probably gets a little power surge as these big caps charge up. That's maybe it just failed from fatigue. of getting hit with that surge every so often. So I'm just going to replace that resistor, and we should have our channel back. Hopefully that's the end of this story. We'll see. Okay, here's our fender. Let's check this out. I'm getting open circuit. Okay, here's the replacement, 10 ohms, fuse resistor, and you got to make sure it's a fuse resistor. It's got to be a non-flammable. See, there's no hard short that, you know, let's look at this close. If this had a hard short, it would have a burn hole on it, or a scorch, or it'd be black in some, but it's got nothing. So I think it just failed from fatigue. It was probably a substandard part they put in, you know, with less than 1%. So it is what it is. Okay. Okay, resistor's back in. One thing I like to do is I like to put it off the board. Got about a 1/2 inch space here. And the reason I do this is if in the future, if anybody ever comes in here again, it kind of signals to them that, oh yeah, this part's been replaced, because it's, you know, different from all the others. And that should draw his attention to that. And if for example, if this part blows again, then he knows there's a problem that hasn't been addressed yet. But it's just an indicator for the next guy, if that makes sense. Now we get this back together. I can't test it until I put the boards in, so I want to go over a few things. This socket here, this is for your quiescent current. You put a plug on here. If you're a factory service, you'd probably have a special plug that you could just plug in there, and then they measure the voltage drop across the 2 pins. I think it's, can't remember, it's 15 millivolts or something. And then this is your bias adjustment here for this channel only. And then each channel has a socket and an adjustment. So you go through and you do each channel. You could just measure across with the pins with a voltmeter and do it that way too. I did check these caps. Both of them are okay. They read up around 450, 470 microfarad. They're fine. I checked this cap here. No, that was it. I checked those two. And yeah, I'm confident we fixed it. Now what I'm going to do is I'm going to go through and I'm going to check caps, especially in this area here. I think you got some cooked capacitors. This heatsink gets very hot. And I'm going to make sure all these caps are good in these power supplies. I don't want to have any bum caps. There's some there, and then there's 2 up here. You can see right here there's a couple next to these heat sinks. So I'm going to make sure all those caps are good. And then I'll do the same for the power supply board. Make sure all these caps are fine. A lot of times these will fail because when it sits in standby mode, this circuit's always powered up and it always sees current. And then there's a heat sink back here radiating heat. And so we might have some cooked caps back here too. Okay, we're all back together. What I did is it took about an hour, resoldered all the connectors on all these cards, and then resolder all the connectors on the main board underneath, just so that there's no cracks. We know that. And all the connectors on the back panel got resoldered. And I think that's about it. I replaced a few caps. I think I replaced, let me count here. I did upgrade my count here. 7 capacitors. And those were the ones that were in this area here, right? You can't see it now, but there's a couple heat sinks and some capacitors. 3 terminal regulators, and there's some. They weren't completely dead, but they were failing. Not that they were as important, because you could probably remove those caps and it'd probably still work. But anyways, let's power this up. Let's zoom in on our repair area. You can see it there. There's our resistor right here. Let's plug this thing in and see if we get smoke or if we just get success. So, not getting anything right now. We should be getting standby power, but we're not even getting that. Okay, so something is not right. Let me check my work, because back here it is plugged in. Power cord's plugged in. For whatever reason, this isn't working. Alright, I had these 2 connectors swapped in the wrong spots. Easy enough mistake to make. Thankfully it didn't do any damage. This one here goes to the front panel power switch or the transformer. I'm not sure. I think it might go to the transformer, and this one's your power cord. So got it right. Okay, so here we go. Next, let's try this one more time. Plugging it in, and there's our standby power. Let's turn this thing on. Made some funny noises, but it is on. Turning it off. Let's try it again. I wonder if that resistor's heating up. I didn't see any smoke or anything. I'm going to assume it's working. Let's hook up some speakers, see if we get a signal through this thing. Okay, so just after filming that last segment, I went with my voltmeter and I tested both sides of that resistor, and there's 50 volts going through the resistor. So the resistor's still intact. It didn't blow after I turned the power on, so I'm confident it's working. Let's put the power back to this, and we'll have a tone signal sent in. Let's turn it on. Except I need to set it for CD. There we go. So, the left channel, right channel, it's working. Now what I need to do is go through and set up the amplifier's bias, because this is too high. I'll go through and I'll do the adjustments for that. Turn this down. So we got our channel back. Okay, bias is set. The right channel was actually pretty close. The left channel was up around 35 millivolts. The setting for this is 15 millivolts for all 5 channels. And I did set it, so this is probably consumption 70 watts more or less, which is kind of crazy considering the day we live in today. Everybody's trying to conserve energy. But if you're going to use one of these amps for just listening to music, and you just want to use the front 2 channels and ignore the other 3, what you could do is just disable the amplifiers by removing the power to them. There's jumpers on the board that jump power from the power supply to the amplifier, and you could just pull those jumpers out and kill the power to those amps, and then you would save all that power. Another thing you could do is just turn the bias rate down on those amplifiers that you're not using, and they'll be still powered up, but they'll be sipping current. If you ever do decide to use them, you could turn the bias back up, or just listen to it the way it is with the distortion. So this is ready to go. I'm going to put the back on and finish this one up. I think I've seen enough of it for one day. Yeah, it's quite a beast. Alright, we're all back together. Here's a look at the parts that went into it. You got 7 capacitors and 1 resistor. Where is the camera? 1 resistor. That's the deciding factor right there, is that failed resistor. And then these caps I replaced just because I could. They were bad. So it's a nice machine. Too bad it's such a beast, such a power hog too. I could see this being used for an entertainment system. It's limited though in its uses. It doesn't have no HDMI. It's it's no network. It's got a lot of stuff against it, but it's still got some life left in it. And yeah, see if I can find it in a new home. Alright, thanks for watching. We'll see you in the next one. Take care.